Hello and welcome to Unit 8 Opener number 7, where we're looking at the same challenge problem we were looking at in Opener number 6, and we're going to learn a new method for solving it, something called linear combination. It's also called elimination, and it's also called line them up and knock them down. So before we solve this challenge problem, which we actually will get to later in this video, we're first going to solve this simpler problem. Name two numbers whose sum is 14 and whose difference is 2. And we set these equations up in opener number 6, x plus y equals 14, and x minus y equals 2. And we already know the answer to these two problems as well. Let me think. It's something about an 8 and a 6, as I recall. So we'll do it, and hopefully we'll come up with that same answer. Okay, well, let's start this. Here is how the linear combination method works. And for this particular problem, it is going to be very, very easy to use. What you do in linear combination or elimination is you combine two equations. So that's why that name exists. And the reason you're combining them is so that you eliminate one of the variables. That's why the name elimination exists. And the way we combine them is we essentially just put a big plus sign out here, and we're going to add the two equations together. And so x plus x is 2x, y plus negative y is 0, and 14 plus 2 is 16. So you'll notice they were all lined up, and we then knocked these out. So we end up with 2x equals 16, which is simple enough for all of us to solve. Divide both sides by 2 and you get x equals 8. Once you have x, you got to go back and solve for y. So we're just going to substitute that into either one of our two equations in order to solve for y. I'm just going to substitute that back into the top equation. So if x is 8, the top equation will be 8 plus y equals 14. And solving for y, I'll just subtract 8 on both sides, and I get y equals 6. So of all the methods we've looked at in video number 6 and now video number 7, this was probably the easiest method, and the method that I think would work really well for our challenge, because our challenge is still going to have this setup of x plus y in one equation and x minus y in the other equation. Now the numbers over here are going to be ugly, but still, when we go to combine these two things, those y's are going to cancel out right away, and we'll just have to do a little bit of simple algebra in order to solve for x. Alright, so that is the linear combination or elimination method. So, you should probably pause the video at this point and see if you can solve the challenge equation, which is here. I'm going to go ahead and do it now, but if you're watching, you probably should pause it, probably should try it on your own first, and then just fast forward to the end and see if we got the same answer. If we didn't get the same answer, then maybe you should watch the whole thing. I'm going to start by solving by elimination, because I think that's going to be the easiest of all. And here I go. The sum of two numbers is 17,284 and 74 hundredths. The difference between the two numbers is 7,494 and 88 hundredths. And I am just going to combine these two equations with an addition. X plus x is 2x. Y plus negative y is 0. And I guess I could do this equation by hand. This subtraction by hand. But I have a calculator here, so why not use that? 17,284.74 plus 7494.88 is 24,779.62. 24 Alright, and I'm trying to solve for x, so divide both sides by 2. And I will get x equals divided by 2, 12,389.81. 81 hundredths. So I found x. Now I just have to go back and find y. I can substitute that x back into either one of the two equations. I'm just going to use the top one again. So instead of x, I'm writing 12,389 and 81 100th plus y equals 17,284 74 hundredths. So I'm subtracting this 12,000 number on both sides, and I get y by itself, and I'm going to use the calculator again. 17,284.74 minus that answer is 4894.93. Check and make sure I got it right. Yep. So here is what I'm getting for the answer using the elimination method. Okay, what I'm going to do next is start all over from scratch. This time I'm going to use the substitution method to do it. So same two equations, x plus y equals 17,284.74, and x minus y equals 7,494.88. And then I'm going to isolate one variable in one equation. Doesn't matter which variable. I'm going to do it the way I did the example in the previous opener. I'm going to add y to both sides to get rid of the y on the left side, and that moves it over to the right side. So now this x is all by itself over here. And now I'm going to substitute this expression into the other equation for x. So I've got 7494.88 plus y equals 17,284.74. So instead of the x, I wrote this expression that's here, and then there's a plus y equals this 17,000 number equals the 17,000 number. Alright, so now I just need to solve this equation for y. I'm going to subtract the 7494 on both sides. Let me get my calculator up here. 17,284.74 minus 7494.88 is that, and y plus y, of course, is 2y. So 2y equals this, 9789.86. Then I divide both sides by 2 to get this y by itself, and I get y equals this divided by 2. Let's cross our fingers and hope it agrees with the last problem, because this will be a long video if I have to remake it. 4894.93. Thank goodness it matches. Y equals 4894.93, and then we're going to substitute that back in to get x. You can substitute it back in either one of the equations you want. I would suggest to you that as long as you did that work to isolate a variable, it's always going to be easier to substitute back into that equation to find the missing variable. So all I got to do is x equals 7494.88 plus y, which we now know is 4894.93. So I just need to take 4894.93 and add 7494.88, and I should get the same thing for x that we had last time. 12,389.81. 12,389.81, and that is in fact what we had last time. Whew. Alright, so I think the moral of the story here is that, particularly when the numbers are sort of ugly, they aren't all nice, easy integers, these algebraic methods of solving systems of equations, elimination, and then this one was substitution, are much easier ways to solve.